So again, my name is Bron Neveau. I'm the CTO of cPacket. With me is Andy, who is Senior Director of Technical Marketing. I'll do the talking and he'll do the demonstrations. So really what we wanted to talk with you about now is, okay, the objections that I always have, and it started also, I remember the first time I started, I had dashboards and we were able to see retransmissions, and I went to the customer and I had 70,000 retransmissions and it was red. So he looked at me and said, well, why is it red? I was like, well, 70,000, that's a big number. So, well, nobody called me, so it can't be that bad, right? So this answer of what is normal, what is abnormal, and what is, in our network observability case, will they get a phone call? In the security world, is it something malicious or not, is something we've been struggling with for the last, or trying to solve for the last 4, 5, or 6 years. So the whole idea there is really, what are you going to do when you don't have the thresholds? And even if you had the thresholds, so let's say you know the application. So you could in theory say FTP is okay, not FTP is not okay, and start giving us many, many thresholds. It very quickly becomes unmanageable. So what you want to do, and this is where you can call it AI, you can call it machine learning. We used to call it machine learning, now we call it AI, is allow us to establish what a normal behavior is. And when we say a normal behavior, we mean by location, by application, by time of day, day of week. So you have temporal, you have physical, you have logical, and all the metrics that we connect. So today on the CCP session, for example, we have like 50 different metrics. We have duration, we have amount of data, we have other things like latency and connection failures and whatnot. So what is a normal for a given location, for a given application? At a given time of day or day of week, sometimes it's event. I think when we talk with here on the network field day, we had some guy from the MLB, and he was like, well, a game time looks very different than non-game time, right? So you have to take all this into account. So that's one thing, right? So you know what is abnormal, right? You know, is a session duration for this service, this type of clients, 2 days is too much or not. And the second thing we want to do is be able to correlate and aggregate and give you one insight versus all the incidents that we see, right? Because what you'll see, for example, if it's a C2, you see typically more than one. You want to kind of bring them all together. Make sense? So we'll give another example. You can apply everything that I showed before. You can apply the same thing. So we'll just use the exfiltration, an example that's, again, we have one of a big AI player that doesn't want that his crown jewels will be the weights of their learning of their model. They don't want that to leave their organization, right? So exfiltration is really about, okay, I have a bad actor in, whether he's uploading his personal hard drive or he's trying to steal the weights. Or I worked in Qualcomm many years back, and they lost the whole source code of the phone when Qualcomm did phones. And that you don't want to happen. And this one can happen in different ways, right? It can be a burst, so you need to react very quickly, or it can be a slow drift, and you want to make sure that you're able to count the session length. Another typical, so this one I'll just click quickly. Another example that you need this baselining is lateral movement, right? So all of a sudden you start seeing traffic between two sessions that are, or between two groups that are not supposed to communicate, or what we prefer before and imply the slow burn DDoS, which is about opening many connections over time, just keeping the connections empty. So it's not something I can detect in the packet broker, but I can detect them in the capture. So these type of things typically will be identified on the packet capture. And the way we do that is we take all the metrics from the session analytics in the packet capture. We put them in a big bucket of metrics, because now you're dealing with you really want to look at the billions and billions of sessions over a day. So we put them right now in an S3 bucket, and we're using the model that this kind of demonstrate in a lot of details, and I'm not going to go through all the details to establish the anomalies. So what we do is basically we look at all the metrics based on, as I mentioned, the physical location, the logical location, and the temporal location. Define what the baseline is, and then start looking for anomalies. So any session or group of sessions that starts deviating for that. And we collect all that to insight. And the idea with an insight is really this card that, again, Andy will show in a second, which should give you in one place a concise description of what's going on. And what's going on means what have we seen, when did it happen, when many times means like every day at 8, right? So when can be a periodicity. Where in your network, and hopefully we can also understand why it happened. So that's also useful, I think. Yeah, so these scanners, for example, is something that you'll always see on your network, but it's also a good indication for people probing you before DDoS, right? Usually you'll see before DDoS a little more activity from newer scanners. So that's something that an insight you can use. Questions?
But you're always being scanned.
Yes.
So when your DDoS comes, you might not be able to figure out which one of them started it.
Right. That's true. Usually what we see is a little higher. So there is also level of scanning. If you build the scanner, if you can restrict the IP addresses that have been scanning you for the last month, you can do that. Yes. Usually what we're seeing is a little higher activity. This is why the accuracy of the detection is important. But yes, anytime we put that, you always see scanners, yes.
Yeah, it's called the internet background noise.
Yes, it's the background noise, totally. I think, what is interesting, what we've seen before here is that many times the IP addresses that we identify were not actually on the restricted list. So it always helps them to increase that, and you can subtract and look for new ones. But yeah, it's not a perfect method. But it is still a little early indication to the DDoS. The DDoS is still going to be there. Okay.
Just thinking from an operations perspective, is your AI going to be able to help any of my ops teams with network troubleshooting?
Yeah. So AI was designed primarily for that. So should watch the network field over the next one. But yes, most of the things we're looking for is around whether it was a server overloaded or network overloaded. So, again, we are coming in from the network observability. So that's the core thing we do. It so happens that we started connecting them to real networks. We started seeing things like suspicious thing that might be an exfiltration, might be a scanner. That was kind of unintended. It's like the 3M Post-it story, right? We went to build the best network observability solution. As we built that, right, they were trying to build to get the strongest adhesive that they can find. They ended up with something that is very easy to tear and became a big seller, right? So we didn't go for observability. We didn't go for security. We went for observability. It just so happens that as we deploy, we start seeing things that are relevant to the SOC team.
So so what I'm going to do here is I'm actually going to show you a live system, which is using our AI observability platform that we're developing now. It's actually out there being used by some of our customers. And basically, this is looking at our entire corporate network. So it's looking at everything in real time. This is not simulated data. This is really what's going on within our environment. So you can see we've got quite a few machines running around in the network. We get a nice little overview of where everything is and how it's all kind of interacting together. But more importantly, the AI engine, the machine learning that's running in the background is constantly analyzing all of that data. And it's actually then generating what we call insights. So these are the cards that get generated as part of the output from the engine. So what it's done is it's looked at, for example, each of the different interfaces and each of the different monitoring points within our environment, and it's looking for certain things. And one of the things it's identified is that there are scanners going on within the network, as we talked about earlier. So, we've identified them at different monitoring points and different places throughout the network. So in this particular case, I'm going to open up, for example, the scanning on our NAT and our VPN interface. So you can see the engine has, instead of it giving you a list of 84 different incidents, it's kind of grouped them all together and said, this is all basically the same old problem, and we're going to group all those together for you. We gives you the information on the last time it happened and the start time, and it gives you a kind of an explanation of kind of what's going on. Now, when I open that insight card, we have kind of an overview of exactly what's happened in the last week. Now, in this case, we're looking at scanners. So it now breaks down those incidents for us over, the last hours, days, week, month, or for however long we've kept that data for. And we can look for, specific days or specific number of counts. So there are a couple of incidents there that are maybe a little bit out of the ordinary that we will, we can perhaps go in and dig into. But what we can also do is we can scroll down now and we can see who are those scanners. So here, for example, we get an information about all the source IP addresses, the countries that they're coming from, and how many times they've tried to communicate and scan that particular monitoring point or that particular endpoint within our network. Now, on top of that, though, I can actually go even further down in there. So because the platform is tied into our cClear management system, I can actually now investigate that in a lot more detail by clicking on the investigation tab and actually now logging in, downloading and getting access to that data. I've already got it loaded, so I'll bring it up here. But effectively what it allows me to do is to now get full access to all the information about that particular host. How many times has that remote endpoint tried to scam the network? How much bandwidth has it been using over the last 24, 48 hours? I have access to all of that information directly within there. I can get a breakdown of each time that has made a scan. I can see which protocols they used, which ports they've gone after. And on top of that, I can also go one step further. And again, just like we can do, or we did with the DDoS or with beaconing, I can actually now go and pull the packet capture down from our packet capture device, our C-store, and I can now open up Wireshark and I can look at all that deep data in real time and actually then troll through and look at what's going on within that packet capture.
Hey, Andy.
So again, I have this ability from a high level to drill all the way down to a single conversation for that scanner.
Hey, Andy, it's Tom Hollingsworth. I got a little piece of feedback for you guys on that table down there.
Yep.
You consider that there are over 65,000 TCP ports and we don't have all of them registered. When you put other, could you maybe have your designer people put the port number in parentheses after other so that we all know which port it is? Because I bet you there's 60,000 other ports. And if I don't want to have to drill into every one of them to figure out why there was something that set 7.3 billion packets, if I knew the port number off the top of my head. So for example, I know it was, audio.
Yeah, absolutely. Yeah, that's something we're actually looking at as part of an extension that we're adding that'll give you a lot more analytics into an application level, which would obviously relate to the ports as well. So yes, absolutely, we can take that feedback.
And the other question I would have is there is such a thing as IPv6, right? So
How well does that fit in there?
You beat me to the IPv6 question? It's okay. Yeah, so I have to ask this on behalf of Nick Baraglio and Chris Cummings and Ed Horley. What is your v6 support?
So the answer is going to be it depends. Some of the features are supported in IPv6, some of them are not.
Okay, is it packet scanning in v6 or is it also...
Packet scanning is supported, some of the TCP analytics isn't, so it's not going to be, it's a long answer. We have a whole thing and we are in the process of adding it. It's not complete.
Okay.
So some of the analytics is, some of the analytics isn't. Yeah. It's a big item on our roadmap, but still on the road. I think the full support is on the roadmap.
Yeah, so the second option we've got here is, as Ron talked about, was, for example, exfiltration. So what I can do is I can utilize the filter to look for have there been any exfiltration attempts within the network. So I can actually break those down and I can look in there and actually I can get a list of all of the exfiltration attempts. And here's an interesting one. So we had, looks like somebody has tried to get access to our security cameras and our alarm system within the network. So I can see when that happened and how often it's happened. So I can open that incident again. And again, I can get a breakdown over time of what that, how many times that particular thing has happened. And again, now I can look at this. And actually, this was something that we didn't even know was going on in our network until we actually switched this feature on within this platform. And Ron, you could give some history, but when we reverse looked up this IP address, it turned out it was our security company that was actually monitoring and managing the system and using remote ports to get access to do that management. And again, we have access to that information just as we do before, so we can actually go in and look at all that information, which ports, etc. So exactly the same as we were doing. We have that level of granularity to understand exactly what's going on.
Yep. Yeah, the way that it was flagged, the reason it was flagged is because the service was defined as a broader service inside our data centers. Later, it's like, okay, so these doors and this is a normal behavior, then you filter them out. We kept them here for a demo so we can show that this is essentially learned what the normal behavior for that group is, and then it was a deviation from that. Okay, I think we need to move on. Is there one more, Andy, or?
No, for this, let's hand back to you.
Will you flag traffic from some Chinese cameras back to calling home?
This one wasn't, but it would have. Yeah. Yes. So I think really, again, it's the two questions that I got, right? It's impractical in most cases to set predefined thresholds. Then what do you do about it, right? That's the answer.